Hi there, my name's Jez Turner. I'm an associate professor at the University of Nottingham, and I'm here today to introduce this topic about Apollo, Artemis, and space sustainability. Really, what we're going to do in these two sessions is we're going to describe differences between the Apollo and Artemis moon programs. And why are we doing that? Because we're really looking at reusability and what that means to a space flight. And then we're going to delve into more in the second seminar session, describe methods of dealing with space hardware that has been used. And then we can really evaluate strategies for making space exploration sustainable for future generations, for you. And this is where you come in. Now, you are going to be the people in the future who will try making the planet a little bit more sustainable. Let's hope we can achieve that. But I think it's very remiss of me to not say anything about China in this context. You walk into this building, University of Nottingham, at the Advanced Manufacturing Building, and there are people from all over the planet here working together. And China are doing amazing things in exploring the moon and future moon bases. And whoever gets there first, it doesn't really matter to us as scientists and engineers. We just want to explore. However, I'm really going to talk about the European Space Agency and NASA programs at the moment. So, what is this an image of? Hopefully, you recognize the Earth there. Now, this was taken in 1968 by the Apollo 8 astronauts going around the moon, being really busy, and then they saw this and went, whoa! And they took a photo of it. Now, this image is cited by many, including me, as being the birth of the environmental movement, thinking about sustainability on Earth, seeing that beautiful blue marble hanging there in the darkness of space, realizing how fragile our planet is. And that is one of the things that happens when we explore space. We find out more about ourselves. Now, this image inspired me. I'm a high school dropout, really dyslexic, and it inspired me to learn more about this wonderful Apollo mission. How on earth did the people on Earth get humans around the moon, not only around the moon, but land them safely on the moon and bring them back home again? That inspired me. And also I learned a lot of science and engineering from science fiction. This is me sitting in the Star Trek original chair from James T. Kirk back in the day. And that got me, that enthusiasm got me to here. This is me at the US Space and Rocket Center in Alabama, where they built the Saturn V rocket. And there, I'm wearing Neil Armstrong's thermal protection glove that he wore on the moon. Please ask me questions about that in the next session. I'm not going to delve into that now. I'll leave that teaser for you to realize that you can come from humble beginnings to become an associate professor at the University of Nottingham. Right, so that image then, like I said, was taken by the Apollo 8 astronauts. So Bill Anders, all that time ago, over 50 years ago there, taking that image. So when it comes to me recording this right now, Christina and the crew of Artemis 2 are getting ready to re-enter the Earth's atmosphere, literally hours away. So I'm super excited. And they, just a few days ago, took this breathtaking image of Earthset. And one thing that they realized as well, and it was really quite overwhelming for them, that moment of Earthset here is when the Earth was going behind the moon, they would drop into radio silence. And having those moments of deep contemplation at seeing, again, that beautiful fragile Earth and realizing there's no borders and humanity could be coming together as one. And I think that mission of hope, and I'm realizing here, this isn't a NASA crew. Half the spacecraft is built by the European Space Agency, and then Jeremy, another Jeremy, I'm Jez, which is also Jeremy, the first Jez around the moon, which is Jeremy there. Jeremy is Canadian. Okay, so it is an international mission nowadays. So we're going to have a look now, and this is the incredible Saturn V rocket. This Saturn V rocket took off, and it was only a tiny little proportion of it that ever was needed to go to the moon and come back again. And essentially they landed this spacecraft, the Lunar Exploration Module, was landed on the moon. All of this was left behind. The tiny little bit at the top here went back and eventually was jettisoned. They came back in a little capsule and the rest of it was just disposed of. So how did that actually happened when originally the Saturn V rocket was meant to be reusable. So Werner von Braun, the German rocket engineer who designed the Saturn V rocket, had this idea of reusing the first stage of the Saturn V, but because of political tensions at the time, essentially it was a race between Russia and America to get to the moon first. Now, actually, it wasn't really a race. The Russian rocket was actually, it failed 3 times. If they'd have taken their time, taken things incrementally, step by step, we would have had reusability in there from the start. Who knows where we would have been right now if that had been the case. But we are where we are. And they got to the moon based on the best possible way they could do it at the time, which is make it as light as possible, as disposable as possible. So the first stage essentially dropped in the ocean, and then there's a second stage, and this translunar injection, this was all dumped, and then some of it is still floating around in space. And then bits of it came off, so lots and lots of sections where reusability was never an issue, never even considered. And it was only really this little command module that ever came back, and they weren't reusable. So how is that different to the Artemis missions? Well, 4% of the whole of the gross domestic product of America was spent on Apollo. And now the NASA budget is about 0.4% of the gross domestic product of America. And here, even though this rocket is incredible, this space launch system that they've just launched on to take the Artemis 2 mission around the moon, it is highly more advanced. It's also bigger. It's also got more radiation shielding. It's also got more complex things, including a space toilet for the first time. So here, that's going to cost a lot more. There's going to be a lot of testing involved. And the risk, we are very risk averse now, but some risk was acceptable in Apollo era. So there's a reason why we haven't been back in so long. A lot of that is political, making sure we look after these astronauts a lot better in the current climate. But how did we get here to that Space Launch System rocket, which is actually based on space shuttle technology that was reusable? So here, this is a space shuttle, here, these rocket engines here were incredible. RS-25 rocket engines, completely reusable, and these solid rocket boosters at the side, completely reusable. Now, going back here, you can see the similarities. These are still the RS-25 engines that were reusable, and now, because the rocket is more complex, actually that gets dumped in the sea, which is heartbreaking. Now, here, these solid rocket boosters used to come back down to Earth on parachutes and were cleaned up and reused from the space shuttle era. Here, they're slightly bigger, which means the parachutes can no longer bring them back down to Earth safely, so they're dumped in the ocean. So we've actually got less reusability over the years. So why on earth are we in this situation? Well, a lot of it is political, a lot of it is because of this risk, and a lot of it is because of funding. So where can we go from here to make space more sustainable? Well, it is actually happening. Now, just to give you an idea and a comparison, the Saturn V rocket produced a thrust of 33 million newtons of thrust, and it was disposable. The Space Launch System, it's got more thrust, and it's still disposable, although the Orion capsule can be reused. Now, looking to the future, New Space, this SpaceX's super heavy rocket, has got twice the thrust of the Saturn V and will be fully reusable. And in fact, they've caught this booster, which is 60 meters tall, a couple of times now. Blue Origin is the new kid on the block, really, and they are having a partially reusable rocket with 17 million newtons of thrust, but they're going to upgrade that very soon to be comparable to the Saturn V rocket. So, reusability is coming, but is it coming fast enough? So why on earth are we using these disposable rockets still, like Space Launch System? Because these new rockets are coming on board. However, they are also not fully there yet. The Space Launch System is the best way of getting people around the moon and back again at the moment. However, we have new rockets that are coming on board. So taking that in mind, let's go back and have a look at Orion in a little bit more detail to kind of wrap things up. So this is actually the Orion spacecraft. We've got the Orion capsule here, but at the base of the Orion capsule is called the European Service Module. Now, the European Service Module is designed by the European Space Agency. Now, it provides water and air for the astronauts. It also provides power. It's also got thermal control systems, so the heating and the cooling. All of that is included. Incredible technology. What happens to that at the end of the flight if we can reuse this capsule? Well, sadly, this just burns up in the atmosphere, and that is considered safe. Now, for many years in the past, what has happened is lots of spacecraft have been up in space, and sometimes they've just been left there. When that was realized that it could be a problem, as well as, well, actually, we can safely dispose of it by burning up these big bits of space debris and pushing them into the atmosphere, and then that's fine because we've burnt it up. Now, as the amount of spacecraft are increasing from hundreds to thousands to tens of thousands, is pushing these bits of incredible technology into the atmosphere and burning them up the best way of solving the space debris problem that we have in orbit at the moment. Is that really what we want to be doing with incredible technology? Well, we are now starting to detect heavy elements of metals and other materials starting to be in the upper atmosphere. Is there another way that we can do this? Could we take this space material, which is incredibly advanced, and repurpose it, or reuse it, or recycle it in some way? That is some of the questions we're going to be asking you in the next session. For this spacecraft here, or is there a way, as when it's coming back down to Earth, steering it out of the way so it doesn't burn up in the Earth's atmosphere, that goes into a stable orbit and then could redock with another spacecraft, be refueled, and then reused again? Is that something that we could do? Now, there's some of the questions that really I'm going to be asking you, and we're going to investigate. So for you then, what are your next steps? I'm asking you this question: what could make space more sustainable? And that's where we're going to launch in the seminar session. We're going to have I'm going to pose a few problems and a few questions, a few scenarios, and we're going to look at some technology. And we're going to maybe have a discussion about the difference between Apollo and Artemis, and if we are going to make this sustainable base on the moon, how can we make it more sustainable and reuse old technology to make the future of spaceflight more sustainable? So we're going to look at methods of dealing with space hardware, and we've got some experts here at the university that have really delved into this, and we can have a look at some methods of dealing with space hardware after it has been used. And then we're really looking forward to evaluating strategies to making space exploration more sustainable. So that is really the thing that you can get involved with, because you will be the future scientists and engineers and that will be able to make this happen. Now, when you think, oh, God, I could never make this happen, I'll just give you these final messages. Remember, I'm someone who left school with no qualifications of note, no A-levels, anything like that, but I'm an associate professor at the University of Nottingham, which is still incredible. And Christina Cook, who is currently getting ready to re-enter the Earth's atmosphere, as a 10-year-old, was walking around the Kennedy Space Center and saw a picture of the Apollo 8 Earthrise and asked their parents, oh, can I buy this? And she took it home and put it on the wall. And when she did that, she said, I wish I could be the person who went around the moon. And look at that. All these years later, she's the first woman ever to go around the moon, and that was because of the inspiration of Apollo 8. So hopefully these Artemis missions are going to inspire you to think about space in a different way, and hopefully inspire you to make space more sustainable in the future. So I hope to see you in the next session, and thanks a lot.